Welcome to power quality lecture. Today we will start the power quality. Uh, what is power quality and uh, what is the reason to introduce this topic, power quality, in the syllabus? There are four reasons why we are going to study the power quality. Point number one is the use of electronics, and microprocessor or microprocessor and controller based instruments or some electrical gadgets we are using, the people are using, and these instruments are very much sensitive with the voltage variation and frequency variation, or say waveform variation. Second is that the second point is that the use of adjustable speed drive, adjustable speed drives, uh, speed drives instead of conventional method for controlling the speed. For example, for the DC shunt motor, the armature control and field control methods are using to control the speed of motor. Nowadays, thyristor family are used for controlling the speed of motor. Similarly, in our home, instead of using resistance type speed regulator, nowadays electronic based regulators are used in the home appliances. Third point is the energy efficiency. Energy efficiency. In case of nowadays, people are very much conscious about the energy consumption and energy efficiency for the electrical gadget. To obtain the energy efficient motors, to obtain the energy efficient system, the gadgets are controlled with the help of power electronic devices, microprocessor based devices, or variable speed drives, or many things which we are using. Instead of, we have replaced our linear load by the non-linear load with the discharge lamp and say LED lamps and so on. So because of these all three or four points, the power quality topics comes into the picture. Now, what is the power quality? First, we will start with the voltage quality. What is voltage quality? The voltage quality, expected voltage of any system should be like that. The waveform or the frequency as well as the magnitude of voltage should be constant with respect to time. Say this is the voltage waveform. The voltage should be constant and it should be a sinusoidal waveform. Then we can say that the voltage quality is good, or it is a healthy voltage. So this is the voltage and this is time t. At maximum at pi by 2 and minimum zeros at this point. Again, it is maximum in negative. So this waveform is symmetrical to the time axis here. This is a voltage quality. Now, what is the current quality? Current quality. In the current quality, say this is the voltage waveform. This is the voltage waveform. For example, this is the voltage V. The current should be in phase. The current should be in phase. The magnitude of the current is depend upon the load. If the load is higher, the current magnitude will be more. If the load magnitude is small, current magnitude will be small. But the waveform should be similar or in phase with the voltage. So it should become maximum when the voltage is maximum and goes to the zero value, become maximum in negative direction, and so on. So here this voltage and current, this is voltage and current is in phase. So this is the current quality. So what is the power quality? So power quality is not only the multiplication of current and power, current and voltage, which we have generally used. Power is equal to V into I cos theta, or for the DC, for the unity power factor, P is equal to V into I. So power quality is not the product of voltage and current, whereas it is the any deviation between voltage and or current from its normal value. Say if the voltage is constant, there is a deviation in current, so it is not a symmetrical, it is not a, say, in phase, or both are deviate with its rated value or normal value. It may be the frequency, it may be the magnitude. Suppose the voltage is constant, and whereas after some time the voltage dips or there is a voltage increase, then it is called as a deviation in voltage, or it may be the current, then it is called as a power quality. So this power quality become a problem, or we can sort out, or we can define is a quality of supply. Quality of supply. To define the quality of supply, it has two parts. One is the technical part, and second is a non-technical part. So this is technical part. And second is non-technical part. In case of technical part, it's a voltage quality. It's a voltage quality. It's a voltage quality. Whereas in the non-technical part is the quality of supply or quality of service. The quality of service is may be defined as the complaints, or it may be the some transparency in electric tariff. So it has two parts. One is the technical and second is the non-technical. In the technical, it is a voltage quality, and whereas in the non-technical is the quality of service. How fast the electrical supplier company, or it may be any organization, respond to the complaints raised by the consumer, or transparency in the electric tariff, because there are different type of consumers are there: residential, commercial, small scale industries, or say commercial establishment. non-commercial establishment, and so on. So the electric tariff should be different for every type of consumer, every category of the consumer, because the use and use pattern is different for the different consumer. Second is whenever the quality of supply, there should be a quality of consumption or consumer. Quality of consumer. It is very necessary that consumer should be aware about the power quality and power quality issues. So for the consumer side, again, there are two category or two part. One is the technical and second is non-technical. In case of technical, it is the consumer consumes or the current depend upon the load. Here is we are not talking about the voltage, whereas we are talking about the current, because consumer is going to consume or it is when the load is connected, the nature of load will define the nature of current. Either the current is lagging, either the current contains more reactive current, more inductive currents, and so on. If the load is non-linear, definitely the current is non-linear. So the consumer is non-linear load, polluting or producing harmonic in the system. So these are the technical part of the quality of the consumer, whereas non-technical part is how fast consumer pay electricity bill. Definitely, if the consumer are paying electricity bill in time, the utility or the supplier company going to upgrade their system or enhance the power quality issues or enhance the reliability and all these things. So this quality of supply also, one is the reliability. No doubt reliability comes into the technical one, but we can consider is a non-technical, means the system is more reliable. This is the two parts. So in true sense, what is the power quality? So one may define the power quality a power quality problem, a power quality problems is an occurrence as non-standard voltage, current, or frequency deviation that leads to misoperation of end user equipment or complete failure or failure of equipment. So what is the power quality? What is the power quality problem? So power quality problem is a occurrence of a non-standard voltage, current or frequency. It may be the combination of voltage and current. It may be any one of them, one of three, that is voltage, current and frequency deviation, that leads to misoperation of end user equipment or the failure of equipment. Many times it is found that there is a malfunctioning of electronic component. It is because of the, it may be the because of voltage dips, or there may be a voltage drop. Similarly, many control equipments, control equipment of the motors or the machine is going to misoperate, is going to trip because of the voltage variations. Or it is found that for the consumer or for the farmer, uh, many times the motor get burn out or the pump get burn out even though the load on the motor is not higher. So it is called as a power quality problem. Now, what are the power quality problem? The power quality problems may be listed as transient, it may be short duration, voltage variation, voltage variation. It may be a long duration, voltage variation, waveform, distortion, voltage unbalance, and voltage flicker. So these are the some points or the power quality problems. One is the transient. Again, there are two type of the transient: short duration voltage variation, long duration voltage variation, waveform distortion, and voltage unbalance, voltage flickers are there. So just we will see what are the different power quality problems and their characterization. Say it is a power quality problem, power quality problems. Then here we can write as a category. Then method of characterization and typical cause. What are the typical cause in the power quality problem? First, it is a transient. And transient, there are two types. One is the impulsive transient, and second is the oscillatory. So there are two type of transient. One is the impulsive and second is the uh, impulsive transient and oscillatory transient. The impulsive transient is characterized by peak magnitude, of the impulse, and it may be a rise time, how much time taken to reach its maximum value, or decay time, or the duration, complete duration for the impulsive transient. And second is the oscillatory. It is peak magnitude, of the oscillatory transient, as well as frequency components. Frequency component. How much frequency components are there? Because it is a, so this two parts is from the impulsive transient, and these two parts for the oscillatory transient. So this is for this one, and this is for the oscillatory transient. What are the typical cause? The is a definitely the peak. It's a step change. So lightning stroke is a natural phenomena. Is a transformer energization. And capacitor switching. These are some possible cause of the transient. Again, the oscillatory is because of the impulsive transient. Impulsive transient. It may be a line loading. And capacitor switching. Capacitor switching. Okay, so this is the first quality, first problem is there. Now second is the short duration. Short duration voltage variation. In the category, it is a sag, that is dip in the voltage, or it may be a swell, and it may be a interruption. So this is 3-1. Interruption. So sag is a sags is measured in magnitude. The method of characterization is magnitude and duration. How much cycle the sag present. Similarly, swell also measured in magnitude. How much rise in voltage, either it is a 0.1 pu, 0.2 pu, 110 pu, and so on. Magnitude and the duration the sag present or swell present. Interruption, it is the duration. How much time there is an interruption, short interruption in the power supply. What is the cause of sag? It is a dip in the voltage. It is a motor starting. Because of the motor draws some inrush current, and this heavy inrush current will dips the voltage, or there is a sag during the starting of three-phase induction motor. It may be a load switching. Heavy load switching in the system is the cause of transformer, or it may be a line to ground fault, and ferromagnetic effect, or you can say that the ferromagnetic transformation. Okay. Now, similarly, the sag, second part, sorry, swell. Swell is the increase in voltage, slightly increase in voltage for the, so it may be a capacitor switching on, or it may be a, say, when the fault occur, line to ground fault occur, the voltage of healthy voltage of other two phases get increased. So it is maybe due to the line to ground fault, or fault in one of the, this one, it is a, or it may be a self-clearing. Clearing fault. So these are the cause by which the swell is going to observe. Whereas interruption, it is only because of the fault and self-clearing. As soon as the fault clear, the circuit breaker reclose the circuit, and power, we get the power supply. So this is first method. This is this is the first problem, is a transient. It has two parts, is a impulsive and oscillatory. It is characterized, method of characterization means it is going to observe by its peak magnitude and rise time, decay time. Similarly, the oscillatory transient is peak magnitude and frequency component. Short duration is a sag, swell, and interruption. Sag is going to measure with magnitude and duration. Similarly, swell is going to measure or characterize magnitude and duration, and interruption is the duration. And these are the some typical causes of the this is short duration voltage variation. Point number 3 is the long duration voltage variation. Now it is, there are again 3 types. Under voltage, under voltage. Second is over voltage. And third is sustained interruption and sustained interruption. So this is 3-1. It is characterized, over voltage is characterized by magnitude and duration. and duration. Second also with the same magnitude and duration, whereas sustained interruption, it is duration. So it is characterized into magnitude and duration. What are the causes, typical causes of undervoltage? It may be the switching of sudden large load, switching on load. It may be switching on load, de-energizing or switching off capacitor, of capacitor, or it may be a de-energizing of the capacitor. Whereas for the overload, over voltage, the causes may be switching off, this is the difference. Here switch is on, capacitor is off, whereas switching off load, switching on capacitor, or it may be the energizing of the capacitor. And dual fault is the duration for the sustained interruption. When the voltages get interrupted, completely interrupted, and it restrained for the long time. So sustained interruption, it is only due to the fault. So these are the next power quality issue or power quality problem and its typical characterization. Fourth point, voltage unbalanced. And it is characterized by the symmetrical component. And what is the reason? It is, suppose the premises or the load comprises of large single phase load, and it is not distributed properly on three phase. So it may be the cause of unbalanced voltage. It may be the single phase load. Large number of single phase loads are there. So this is the fifth power quality problem, is a waveform distortion. And it is categorized as harmonics, DC offset, or notching, or notches, isn't it? So harmonic, it is characterized in the total harmonic distortion, whereas DC offset is the voltage and current. Whereas, sorry, this is voltage and current, and whereas notching is not characterized. Say, what is the cause of harmonic? Is the non-linear load. Non-linear load. We'll see one by one. What are the different? It's maybe a adjustable speed drives, VFDs, variable frequency drives, and so on. And DC offset. DC offset is the use of half wave rectifier, and it may be the inrush transformer current. Sometime because of switching on instant, the inrush current may be asymmetrical to the axis, or it may be shifted to the positive direction and negative direction. So DC offset in the positive and negative. Then it is the notching, is the SCR commutation overlap. So because of the SCR commutation overlap, notching is going to observe in the voltage waveform. 6 point is the voltage flicker. Voltage flicker, it is characterized by frequency of occurrence. What is the frequency of occurrence of the voltage flicker? Is fast, it is periodic, and so on. So it is the reason of voltage flicker is arc discharge lamp, it may be due to the arc welding, and arc heating, or arc furnaces are there. So these are the typical cause of this one. So it is the first is the transient, and it has two part. One is the impulsive transient, and second is the oscillatory transient. And the reason is lightning stroke, transformer energization, capacitor switching, and line loading, capacitor switching. These are the oscillatory as well as the impulsive. Whereas the short duration, it is three types. One is the sag, second is the swell, third is the interruption. The sag and swell is characterized by magnitude and duration, whereas interruption is characterized by the duration. The possible causes of sag is motor starting, because motor take the large starting current, load switching, line to ground faults are the cause. Whereas swell, that is increase in voltage by 10% or 20% for the short duration, it is by the capacitor switching on, that is energizing of the capacitor, line to graph fault is there. Whereas interruption is the fault and fault clearing method. Third is the long duration. Third is the long duration. And in the long duration, again, three type. First is the under voltage, over voltage, sustained fault or sustained interruption. Okay. So it is measured in magnitude and duration, and sustained interruption is duration. The possible causes of under voltage is switching on load, large load is switch on, switching off of capacitor or de-energizing the capacitor, switching off. Whereas for the over voltage, switching off the load, when the load is switched off, the voltage get increased. Switching on the capacitor, that is the capacitor energization. And whereas for the sustained interruption, it is the reason is fault. Next is voltage unbalance. The voltage unbalance is measured with the symmetrical component, and it is due to when the load is comprises of large number of single phase load, that is the lighting load, and definitely or many times the load is not properly distributed over the three phases, and it will lead to the unbalanced voltage in the three-phase system. Or it may be only the single phase load, like large number of single phase motors are there, definitely it will make the system unbalanced. So this is the next. Next is the waveform distortion. The waveform distortion is in the three type. One is the harmonic, second is the DC offset, and third is the notches. Harmonic is characterized by THD, total harmonic distortion. Total harmonic distortion. It is due to the nonlinear load. It may be a SMPS which we are using in the computer, or it may be inverters or converters which we are using. It is due to the adjustable speed drive. In case of adjustable speed drive, there is a switching mechanisms are there and variable frequency drives. DC offset is going to observe because of the half wave rectifier, whereas the notches are because of the SCR commutation overlap. And no doubt we are using the SCR in the VFDs and all these things, non-linear load. The voltage flicker is going to characterized by frequency of occurrence, and the voltage flicker is due to arc discharge lamp like sodium vapor lamp, mercury vapors lamp. It may be arc welding and arc furnaces are there. So these are the some category of power quality problems. Their characterization, method of characterization, and some typical causes which produces the power quality issues. So next time we'll see the again category and some description of power quality problem. Thank you.